In today's video, we'll be building the League of Legends profile scouting site, op.gg, from scratch. If you're looking for an entry-level React project and you also happen to be interested in games, this is a great way to get started with web development. Here's what we'll be building. On the top, we have this navbar where you can enter your game name and tagline and select a server. Then we'll be able to see the player's icon, name, level, current rank, along with a brief match history. We can see more match details by clicking on the down arrow, and we can even click on another player in the match to load their profile instead. If you want to check out the project for yourself or just want some reference code while you do the project, the GitHub repository link is in the description below. We'll start by setting up the starter code, and then we'll take a look at the Riot Games API and how we can actually access player information. Then we'll configure our project so everything runs smoothly, set up our backend server, and then start developing the front end. To create a new React project, we'll be using Vite. In addition to being a build tool, Vite acts as a development server with instant hot module replacement, meaning that any changes we make will instantly update in your browser. Make sure that you have npm installed, then run npm create vite at latest. If you don't have Vite installed, it will ask you if you want to install it. Let's name the project scout-gg, select React for the framework, and Typescript plus swc for the variant. Now we can run these three commands. Go to localhost port 5173 and see our website up and running. Now the key part of this project is the Riot Games API. Riot offers a pretty extensive and free API service for all of its games, where you can access details about the current state of the game, splash arts and icons, player match history, rank leaderboards, and a lot more. To get an API key, all you have to do is go to developer.riotgames.com, log in with a Riot Games account, agree to the terms of service, and then generate a key. This key will expire every 24 hours, so if you plan on doing this project across multiple days, just keep in mind that you'll need to refresh it every single day. In order to access information, we'll need to make some REST API calls. Requests are sent to API endpoints, which are specific URLs on a server that handle particular tasks, like retrieving data, creating new records, or updating existing data. To test these endpoints, we can use something like Postman, which is free for individual use. Using Postman allows us to see how the return data is structured and also to test various endpoints before implementing them in our projects. This part is optional, but I highly recommend doing this because checking endpoints before you start developing is always a good practice, and it only takes a few minutes of your time. Once you're in Postman, create a new collection and name it scout.gg. In the authorization tab, set the auth type to API key, name the key x-riot-token, all caps, and paste your key. When we send an API call, this key is sent along with it, and the backend uses this API key to identify us. For this project, we'll only be implementing 3 servers: North America, Europe West, and Korea. Each server has 2 values, a regional routing value and a platform routing value. Regional values are for broad areas, and there's only 4. Americas, Asia, Europe, and SEA, or Southeast Asia. Then there's platform routing values, which are specific to servers like BR1 for Brazil, EUW1 for Europe West, TW2 for Taiwan, and so on. If you want to implement other servers beyond the 3 I mentioned before, you can find a full list of routing values from the developer docs, which I will link in the description. Back in Postman, let's create 2 variables, region and platform. Enter the values for the server that you want to test. Now, by the time you watch this video, Riot Games might have updated the API to a new version. Check the link in the description for each endpoint I'm about to show you to see if you need to use a different URL. Let's start by testing the first endpoint, which will return a unique player ID given the player's game name and tagline. Create a new HTTP GET request and copy this URL, which is also linked in the description. Replace the values at the end with the game name and the tagline. If everything works correctly, you'll get a response like this. This unique player ID is what we'll use to identify the player in future requests. We will not be using the game name and tagline. Let's test the second endpoint now, which will return some summoner data given the unique player ID we just got. Again, create a new HTTP GET request, copy the URL, and replace the value. Here we can see information about the player's icon and their summoner level. Now, following the same process as before, let's get information about the player's rank. Here we can see information about the ranked mode, the rank, the LP, and the number of wins and losses. Finally, we can get match data from the player's most recently played games. For the fourth endpoint, we can specify how many matches we want to get in the parameter section, and we'll get a list of match IDs. We can use these IDs in the fifth endpoint, which will return the match data for that match ID. There's a ton of data here, but most importantly, there's some general match info here, like if the game was completed, the game mode, as well as all 10 participants and all their stats during the game. Alright, now that we've checked all of our endpoints, let's start configuring the project by removing the default content vite created for us on this page. In your code editor, remove everything from app.css and index.css. Then go to app.tsx and remove everything inside the function and delete the imports at the top. We also need to store our API key in a secret file because we don't want it being leaked to the public, so create a new file and name it .env. This is going to be an environment variable file. Create a variable called Riot API key and paste your API key in. If you plan to push this to a GitHub repository, make sure you add this file to your git ignore so the API key doesn't end up public. Alright, let's find a good icon to use for our favicon and logo. You can go onto a site like FlatIcon, type in something like swords. I like this one right here, so I will download the 512 by 512. And now we can replace the favicon in the public folder and the logo in the assets folder with our chosen icon. Now, the reason that we separate them is because the public folder is for static files like favicons that aren't processed by vite. The source/assets folder is for images and files used in code, which vite can optimize. In the index.html file, we can change the title to Scout and change the link href to whatever your icon is named in the public folder. If we go back to our browser, we can see the changes at the top. Nice. Now, next we'll need to install some packages for styling, components, and utilities. So open the terminal and copy what you see on screen. Alternatively, you can copy it from the description. Headless UI is for components, hero icons is for icons, tailwindcss or tailwind is for styling, axios is for making API calls, cores is for handling server security, .env is for handling private environment variables like our Riot Games API key, Express is for building our backend server, and React Router DOM is for page routing. We also need some developer dependencies, which are tools that we use only for development and don't affect how the website actually runs. Make sure you include the -d tag, then install ts-node and these three TypeScript type definitions. To make the backend server development a little easier, you'll also want to install nodemon. Nodemon will automatically restart our server when we make changes. Otherwise, we'd have to type out a command every single time we make a change and want to see those updates live. Make sure you install this globally with the -g tag. All right, after installing, if we check our package.json, we can see all of the dependencies and developer dependencies here. In order to keep our project organized, we'll be creating folders for different parts of our application. We already have an assets folder, which will store all media, so let's create an API folder for all API calls, a components folder for managing React components, a data folder for static data, an interface folder for API responses and custom objects, a pages folder for managing our pages, and a utils folder for managing utility functions. Now, we're only going to have one page on the site, but you can always add more later, so add a new file in the pages folder and name it home.tsx. Create a new constant called home, and for now, let's just return a div with some text inside and export it as default at the bottom. Next, go to tsconfig.app.json and remove verbatim module syntax, and do the same in tsconfig.node.json. All right, let's configure two of the packages we installed earlier, Tailwind and React Router DOM. The instructions for Tailwind are on their website, so let's go to vite.config.ts and add these lines in. Add this line to index.css. Finally, open eslint.config.js, add a new rule called no explicit any at the bottom, and set it to off. For React Router DOM, open app.tsx, and at the top, we'll import browser router, routes, and then route from the React Router DOM package. Inside the function, return browser router, and then add routes inside that, and finally add a new route. In this route, we can specify a path. In our case, we just want it to be the root, and we can also specify an element, which is our homepage that we just created. Notice that once you press tab to autocomplete, it automatically imports at the top here. We'll use that a lot throughout this tutorial. Now we can check our site and see that the text is there. Nice. If we change the path to something like /home, it will disappear, and we can view the page again by going to the /home route. So if you ever want to create more pages, you now know how. You can just add new routes and specify a new path. All right, let's check out some of Headless UI's components on their website. They've got a lot of them, but the ones that we'll be using are button, input, and listbox. Let's take a look at listbox, for example, and this will be helpful when allowing the user to select a server to search a user on. Before we continue, let me show you the desk that has been making my dev workflow way more comfortable, courtesy of today's sponsor, FlexiSpot. FlexiSpot is one of the biggest names when it comes to desks, and that's because their desks are some of the best. Most people tend to settle for a typical two-leg desk, and I was one of those people until I realized how much stability, support, and comfortability I was missing. This is the FlexiSpot E7Plus, a 4-leg standing desk that can handle up to 540 pounds or 200 kilograms. That's more than double what most desks can handle, and more than enough to support both of my monitors and all of my accessories. With 4 legs instead of 2, it doesn't wobble, even when it's fully extended. It can extend up to 51.5 inches, higher than any other 4-leg standing desk currently on the market, and it also comes with a USB charging port, 4 programmable height buttons, solid build quality, a 15-year warranty, and a 30-day risk-free return service. Other standing desks with specs like these might cost you upwards of $1,000, but all of FlexiSpot's desks are surprisingly budget-friendly without compromising on quality. Check out the E7 Plus and FlexiSpot's other models, along with a discount code from the links in the description. All right, let's start working on a little bit of the front end before we move on to the back end. In the components folder, create a new file called navbar.tsx. As a general rule of thumb, .tsx is for components and .ts is for all other TypeScript files. Create a new constant called navbar and export it. And for now, it'll just contain our logo wrapped in a div. Now we can go back to our home page and use our navbar components. Now the logo looks way too big, so let's make it a little smaller by using a Tailwind class. Tailwind works by assigning classes to HTML objects that correspond to predefined CSS classes. So for example, let's give our logo image the class size8. Great, that's way better. I also don't really like how close it is to the edge, and we also want the entire navbar to be off of the corner and the edges. Let's give this div on the outside some padding. Now let's create a new div with an input inside. Make sure the I in input is capitalized so we can use the headless UI version, not the default HTML version, and we can see the search bar is right below the logo. It's not very visible, so let's put some placeholder text. And let's create another one for the tagline. Let's also add a search button too. Now, what we really want is for this search bar to be horizontally centered relative to the width of the screen. So again, we can use Tailwind classes on this parent div here to center all of the items. Absolute allows us to place the search bar relative to the closest positioned ancestor, in this case the screen, then left 1/2 to offset it by half the width of the screen. But we want it to be centered, so let's bring it back by half the width of the div. It doesn't look very centered right now, and that's because all of the items are shifted on the left side of the div right now. We also want the logo and the search bar to be aligned vertically, so we can assign this parent div the class name FlexItemsCenter. Flex is basically a layout system that lets you control how items are placed in a container. For example, let's give our search bar div the class name FlexCall. This will arrange the items so that they're in a column. Obviously, this isn't what we want, so let's change it to FlexRow. Right now, it doesn't really stand out, so let's make it pop by rounding the corners, adding a drop shadow, and adding some padding. Now we can see that the div is centered horizontally. We also need to allow users to select a server. Since we want to abstract this server list so it can be easily updated to add new servers later on, create a new file called servers.ts in the data folder. Let's make an array called servers, and each option in the list will have 3 different properties: an ID, a label, and a value that contains both the platform and regional routing values. Now I'm going to add 2 more servers, Korea and Europe West. Again, if you want to implement servers beyond the 3 I have here, a full list of routing values will be listed below. Let's also make sure to export it so we can use it in other files. Now we are using TypeScript, and one of the best things about TypeScript is that you're able to type objects. So let's make sure that we type these objects so that we're able to safely use each of the values later on. Create a new interface file called routing, and we're going to define 2 different interfaces here. The first is the routing info. There's 2 values, the region and the platform, and both of them are strings. The second interface is the server option, which we just created. This one has 3 values: an ID number, a label, and a value, or the routing info. Back in the server list, we can type the object to be an array of server options. Now we can add a list box from Headless UI. The listbox button controls the button the user clicks to open or close the dropdown, and will use it to display the currently selected server. The listbox options renders the whole list of available options to select from. Let's import our list of servers. And now we can map each object in the server to create a listbox option. The key should be equal to the server ID. The value should be equal to the server, not the server value. And the display name of the option should be the label. In order to constantly track the currently selected server, we'll need to use a state variable. Create a new constant above the return statement, and we're actually going to create an array. This array follows React's useState hook, and it will hold 2 values, the current state and a function to update that state. Now you might be wondering, if we just need a value that we can change, why not define a regular variable using the let keyword? Well, there's a slight problem. We can update this variable all we want, but the page will never re-render, meaning that if we select a different server, the value in the list box won't update. Not very helpful for us. That's because React doesn't know when a regular variable has been updated and won't trigger a re-render to update the site. Instead, we can use useState. This allows React to track the value internally and re-render the component whenever the value changes. This state variable will have the type server option, and let's set the default value to be the first server in the list. We can now add a label to the list box button. When we click on the dropdown, it looks pretty clunky and the selected value doesn't update when we choose another server. To fix this, we need to set the value of the list box to the currently selected server and add an onChange handler to update the state when a new option is selected. If you hover over the onChange function, you can see it passes in the value of the server you clicked on. So we can define a function like this. And this is because we're passing in the selected server directly into the setSelectedServer function without any extra logic. Now if we select a different server, we can see it update. Alright, this looks pretty awful. Let's style it a little bit. First, we'll wrap the entire list box in a div and add some margin on the right side so it's separated from the inputs. Let's give the list box button a blue background, make it rounded, and add some horizontal and vertical padding. Make the text white and make it so that when you hover over the button, it changes your cursor. Let's change the list box options to be on the bottom instead of on the side. And let's also make the background blue. Make it rounded, change the cursor, and add a small margin between the button and the dropdown. Finally, for each of the options, let's change the background color when hovering over it. Add the same horizontal and vertical padding, make the text white, and center it. Let's start styling the input boxes and search button. I really don't like how there's this blue border, and I also think that the tagline input box should be a little smaller than the game name input box. We also need to store the game name and tagline in state variables. Create two at the top, and they should be a string. Then we can set the values to the respective variables and add the onChange handler to set our variable. For the search button, we want to enable it only if the user has inputted both a game name and a tagline. Let's also change the appearance depending on if the button is enabled or not. Since we're planning to use variables in a string, we need to use backticks, usually right below your escape key. To write an if-else statement efficiently, let's use the ternary operator. If both the game name and tagline inputs aren't empty, the cursor should be pointer and the background should be blue. Otherwise, the cursor should be not allowed and background should be gray. Let's do some more styling. Like all the other buttons, make it rounded, give it some padding, and make the text white. Let's also add a small transition when the color changes. Last thing for us to do here is for the search function to be called when the button is clicked. We're going to be passing a function into this navbar that we can call. Define a new interface at the top called navbar props or properties, and it only has one property, handle search. It's a function that takes in a game name, a tagline, and routing info, and returns nothing. Then let's add it as an input to our navbar. Extract the handle search function and pass it into the search button onClick handler. And awesome, we're completely done with the navbar. Since the next few components, the summoner profile and the match list, require us to retrieve data from Riot, let's work on our backend server. Create a new file called server.ts in the API folder, then open a new terminal and type nodemon source/api/server.ts. Now, you might be wondering, why don't we just make the API calls directly from the front end, and why do we even need a backend server in the first place? Riot Games already has a server for us. Well, exposing API keys or tokens in the front end is risky, and by routing calls through our backend, we can securely manage our credentials, apply some custom logic, and better handle things like rate limiting and logging. Let's create a simple endpoint just to test. Import Express at the top. Initialize a new Express app and set the port equal to 3000. This will host our server on localhost port 3000. Notice that when we save the file, the server will automatically restart for us. This is really helpful when testing and fixing bugs. Create a new get endpoint called status, and for now we'll just send a simple message back. To have the server listen for API calls on port 3000, we just need to call app.listen. Now, if we go to localhost port 3000/status, we can see our message here. Now, if we want to include parameters, say we want users to be able to pass in a game name and a tagline, we just need to get them from the request. Like we did with the Tailwind class before, we can include these variables in our response by using template literals, which are strings enclosed in backticks. Then, to include the variable, add a $sign with curly brackets, and then let's stringify the JSON value. Now if we go back to our browser, we can add a parameter like name and set it equal to a value and see it in our browser. All right, let's start building our server for real now. Import axios, cores, and .env. Then configure .env. We'll also need to import our Riot API key from our environment variables. Define an interface called Riot Params, and this will contain all of the info that we might need to send to the Riot Games API, basically like what we did in Postman. We'll need the game name, tagline, region, platform, player ID, count, and match ID. We also need to make the values optional by adding a question mark, because this contains the parameters for every endpoint and not necessarily for a specific endpoint. For example, when we're getting the match info, we only need to send the match ID and not the game name, tagline, etc. To allow our frontend to send requests to the server, we need to set up cores to allow requests from localhost port 5173, which is where our site is currently hosted, and block requests from all other origins. All right, let's create our first endpoint, which will return the player ID. We need to make the function asynchronous since we're waiting on an external API to return data. Now we can get the parameters we need from the request and extract the game name, tagline, and region from that. If the game name, tagline, or region is not present for some reason, then we need to throw an HTTP 400 error and let the client know that it's missing some parameters. Now we want to use a try-catch block to call the Riot Games API and handle any errors that occur during the request. Create a new constant called response, and we'll use axios to make the API call. I'll leave all the endpoint URLs in the description. Again, by the time you watch this video, Riot Games might have updated the API to a new version, so check the link in the description for each endpoint to see if you need to use a different URL. Once we get the response, let's send the response data back to the client as JSON. If we catch an error, let's do two things. First, let's print it to the console so that we can debug easily. And then let's also throw an HTTP 500 error and send the message back to the client. Just like in Postman, we have 5 endpoints in total, so let's copy this and rename it to summoner data. This time, we'll be taking in the player ID and platform as parameters, and let's also change the parameters in the missing parameters statements. Finally, copy the second endpoint URL in the description and replace their URL in the axios request. Now we just need to do this 3 more times for each of the other endpoints. The ranked data endpoint takes the player ID and the platform as parameters. The match list endpoint takes the player ID, count, and region as parameters, and the match data endpoint takes the match ID and region as parameters. Perfect, now we're done with the server. The next thing we need to work on is the summoner profile. This will include the player's icon, their name, level, and rank. For the summoner profile and the match list, we need to create an API layer in the front end so we can keep things clean and organized. Instead of calling the backend directly everywhere, we can just call a function. This makes it easier to change the URL later, keep our API key secrets, and handle errors in one place. Another advantage of abstracting the Express server is so that we can add a return type, so our frontend knows exactly what properties the return object will have. Create a new folder. All the interfaces in this folder will match what the Riot API returns to us. Let's define a few that we'll need for the summoner profile. Riot user data with properties player ID, game name, and tagline. Riot summoner data with properties profile icon ID and summoner level. And Riot ranked data with properties queue type, tier, rank, league points, wins, and losses. Add a new environment variable called the vite API base URL and set it equal to localhost port 3000. If we decide later down the line that we want to host our backend server on a live server instead of just locally, all you'd have to do is change this URL. Now we can start on our API layer. Create a new file in the API folder called the user. Since we're using this code in the front end and not the back end, like our Express server, we can use Vite's built-in environment variable system to get our API base URL. We'll have 3 functions in here. The first one will be to get the player ID given the username and tagline. The return type for this will be a promise of axios response of type Riot user data. Basically what this means is that we are promising to return an axios response object where their data contents match the Riot user data interface. Then we just need to query our backend server endpoints and pass in the variables. These will also be linked in the description if you want to just copy and paste them. Copy and paste this function twice for get summoner data and get ranked data, and we just need to modify the input variables, the return type, and the endpoint. Get summoner data takes in the player ID and platform and returns Riot summoner data. Get ranked data takes in the player ID and platform and returns an array of Riot ranked data. Now we can create a new component called Summoner Profile. We're going to need to pass in some props like we did with the navbar, and since this interface will be used in the home page, make sure to export it. There's also one more variable that this component needs, and that's the Data Dragon version. Data Dragon is Riot's official tool that gives you images for League of Legends like champion icons and splash art, rune icons, item icons, summoner profile icons, and more. Let's include that in our props. Now, the layout for this is going to be pretty simple. Create a div where all the items are centered across the horizontal axis, and now let's put the summoner profile icon in. We can access all the icons from this website. So for example, if I change this to 10, you can see we get a different icon. Add an image, and the source will be the site we were just on, also linked in the description. And as usual, enclose the string in backtick so we can add in our variables. Let's style it a bit as well. Now we need to include the rest of the information. First up is the game name and tagline. Then the summoner level, and finally the ranked information. The player might not have played any ranked games this season, so if there is ranked information, then we'll render that. Otherwise, let's just return a string that says there's no ranked information available. Now that the summoner profile is complete, let's test it out. Create a new utility file called search. Start by getting the user data so we can extract the player ID. Then let's get the summoner data, and finally the ranked data. Return all three at the bottom. Back in the homepage, we need a search function to pass into our navbar so we can populate the summoner profile. The search function we just created returns the data from Riot as it is, and we need to extract specific values to pass into the summoner profile. We're going to have to modify the ranked data. By default, it's returned as an array, where each object in the array represents a different ranked mode. If the ranked data array in the response is larger than 0, then let's check each object and assign the ranked data variable accordingly. This information also needs to be stored in a state variable. Since this is all the info we need for the summoner profile, it will be of type summoner profile props or null. Let's set the default value to be null since there's no user search when the site loads. Let's also reset it every time a new user is searched. Now we can set the current summoner data. The last thing we need to pass into our summoner profile is the data dragon version. The full list of versions is available on this side here, so what we need to do is grab this list and pass in the first version here. Create a new file in the API folder called ddragon and copy this code from the link in the description. Then let's create another state variable called ddversion. And we'll use the useEffect hook to call it when the homepage loads. Since the DataDragon version doesn't update every time we search for a new user, we don't want to get the latest DataDragon version every single time in our handled search function. This array at the end is called the dependency array, and if we wanted to run this useEffect hook every time the current summoner data updates, for example, we would put it in the dependency array. If we leave it blank, it will only run when the home page is first rendered and will not run again. This is perfect for our use case. That's what we want. Now we can pass the handle search function into our navbar and pass the current summoner data into the summoner profile. Let's wrap it in two divs to center it on the screen vertically. Restrict the width, and add a margin between the navbar. Then we can easily conditionally render the summoner profile based on current summoner data. Now we can pass in the current summoner data and the DataDragon version. Include this exclamation point to assert that the value will be non-null. All right, let's test it out. It looks a little off-centered for now, but once we add in the match list, it'll look normal. Speaking of which, that's all that's left to do now is to implement the match list. Again, we'll need to create some interfaces. First is Riot Summoner Match Data with properties win, Riot ID game name, Riot ID tagline, player ID, champion name, kills, deaths, and assists. Then Riot Match Data with properties QID, end of game results, and participants. We'll be modifying the raw data Riot sends us, so we'll also need summoner match data with properties game name, tagline, champion, kills, deaths, assists, and KDA. And finally, match data with properties game type, winner, current summoner did win, current summoner match data, blue summoners, and red summoners. Let's create another API layer for the match data. We're going to need the same API base URL as the user file. This time there's only two endpoints. The first one is to get a list of the most recent match IDs. This will take in the player ID, the number of matches, and the region. the return type will be a list of strings. The second endpoint will be to get the match data given the match ID and the region. The return type will be Riot match data. Instead of just returning the response, we want to return the info field of the response. This is where all of the game data is stored, and we don't need the rest of the response from Riot. Since we're not returning a standard axios response, remove it from the return type. The last thing we need to do before working on the match list components is to add these new API layer functions to the search utility. Let's get the 10 most recent games. And then for each match ID, get the match data and add it to the list. We could use this data as is, but there's so much data that we won't end up using. To narrow it down, let's create a utility function to extract only the data that we actually need. Copy both of these files from the links in the description. The first one, Q, returns the game type as a string given the game type as a number. The second one, match, compiles the match data from the Riot match data type to the match data type. Certain things are added like KDA calculation and which side won the game. Then we just need to call this function in our search function and return it alongside the other data. Let's update the handle search function in the home page so we can test the match table. We'll need to store the match data in a state variable, so let's create one. Then we want to reset the match data every time a new user is searched, just like the summoner profile, and set the match data after we get the compiled match details. What we're going to do is we're going to create a component that renders details for just one match, then map each of the match data details to render all of the matches. Create a new component called match table, and like our navbar, define a props interface. There's two parts to this match table. The first is the unopened view. Then when you click this button, more of the match details are shown. The table is colored based on if the current user won or lost, so let's start with that. Inside this div, we're going to include information like the game type, if the player won or lost, the champion they played, their stats, and the players in the match. All right, let's test it out. Back in the homepage, just like the summoner profile, conditionally render the match data list based on the current match data. We want them to be vertically stacked, and there should also be a small gap between each match. Then, for each object in the match data list, we want to render a match table for it. We need to pass the handle search function as a prop because if the user clicks on another player's name in the match, their profile and match history will load. Since we know that the routing info is the same, let's store the current routing in a state variable and pass that in the function. After the user has been successfully searched, set the current routing to be the inputted routing. The match table handle search function should only take in a game name and a tagline, and then it should call the handle search function on the home page with the game name, tagline, and current routing variable we just created. It doesn't look great, so let's do a little bit of styling. Add a bit of padding, center all the items along the horizontal axis, and round the corners. Let's style the game type and outcome a bit too. Next, we need to display the icon of the champion that the player played. Again, we're going to use Data Dragon, this time on a different URL. To the right of the icon, we need to display the current summoner's kills, deaths, assists, as well as the KDA for that game. Next up is the player list. Since we need 2 of them, 1 for each team, let's create a summoner list component that we can reuse. The props for this component are the list of summoners, the data dragon version, and the handle search function. The players should be stacked in a column with a small gap between each one. Then, for each summoner, return the champion icon along with the game name and tagline. When the game name and the tagline are clicked, the user should be searched. Back in the match table, we can now use the summoner list component. There should be 2, one for the blue team and one for the red team. Not exactly what we want. We want it to be as far to the right as possible, centered horizontally, side by side in row format, and with a bit more of a gap between the 2 teams. Finally, let's add an icon to open up the detailed data panel. And the basic match details are done. If you click on another user in the game, you can load their profile instead. Now we can start on the detailed data panel. Just like all the other components, create a new file, define the props, and export it. The way it's going to work is that the winning team's half of the panel will be colored blue, and the losing team's half of the panel will be colored red. At the top of the panel, let's put which side they are, either red or blue, and if they won or lost. Then we're going to map all of the summoners and display their name, champion icon, scoreline, and KDA. Just like the other summoner list, if a username is clicked, let's call handle search and load their profile instead. When the user clicks the arrow icon, we should display the detailed panel, and if they click it again, it should disappear. To implement this, create a state variable called isOpen at the top. Then, when the icon is clicked, set isOpen to the opposite value of whatever it currently is. Let's add some styling, and we can also animate the rotation of the icon as well. Then, we just conditionally render the detailed team panels. Nice, looks like we're done with the match table list. The very last thing, and one of the most important things to do before our site is done, is error handling. If the API key is outdated, if the user doesn't exist, we need to let the user know that something went wrong instead of just displaying a blank page. Back in the home page, create a new state variable called error. When we search for a new user, we set the error. We're going to wrap all of this code in a try-catch block, which will catch any error that we get. Set the error message to be an error occurred while searching for the user, and then print the error to the console. Then we can conditionally render the error under the navbar. Let's test it out by inputting a username that doesn't exist. Perfect, we get the error message and our console displays the error. And that's it, we've recreated a mini version of op.gg. If you're looking for some further extensions, here are some ideas. The first is caching data. Riot has a limit on how fast you can send requests, so if you wanted to launch this site for hundreds or thousands of people to use, you would start running into some problems. To fix this, you can do something similar to op.gg, where the user data is stored in a database, and only when the user clicks an update button is the Riot API called to refresh the data. Another feature that op.gg uses is URL parameters. This would be something like op.gg/lol/summoners/platform/game name/tagline. If this sounds interesting, look into React's use params hook. I'll leave a link in the description. You could also expand the site to include different games like TFT or Valorant, or even non-Riot games that offer APIs as well. If you want to try hosting it somewhere, I also have a guide on that which you can check from the link in the description below. And if you're looking for something a little simpler, try adding some more detailed game information like player summoner spells or items that were bought during the game. Riot actually already returns that data to us, but we specifically have our interfaces set up so that we only include the data that you see on the site right now. All you'd have to do is modify the current match data interfaces and the match-related functions and find some way to display it yourself. All right, hope you enjoyed this tutorial.